top of tower. Consider, so in this situation, so a projectile from top of tower. So there are three cases. We will see this one. So particularly in two-dimensional motion. Dimensional motion, where project a particle from top of tower. So there is a case one. Consider the tower of height h. Say tower. So its height is h, and this is the ground. Consider a particle projected horizontally. Suppose horizontally, if I project a particle from top of the tower with speed u. So immediately take that point is origin. Take this point is origin, and time t is 0. So this particle, this projectile, it will follow this path. Projectile will follow this path. Finally, it will reach ground. So here gravity acting vertically downward direction. So this is Ay, we call it Ay. Ay is G, we know. But it is minus G or plus G. See, when I project a particle horizontally, it will always goes down. So take downward direction is positive. So consider a coordinate system where upward direction is negative, upward direction is negative, down direction is positive. Because when we project a particle, it is as well as it is going right side. So take right side is positive and left side is negative. So this is a positive x-axis. So this is positive and this is negative. And from where we are projecting, that is the origin. So this will be positive x-axis plus x, and this is minus x, this is minus y, and this is plus y. From where we are projecting, that is origin. So finally, this particle will reach from bottom of the building. From bottom of the building, from here to here, this distance is called range. We call it range R. And building height is h. H is the building height. So how do we apply kinematic equations here? So before we want to apply kinematic equation, is the direction of gravity. So gravity is downward direction. So downward direction is positive. So plus g. Acceleration along y direction is plus g. And particle is moving right side. So along x-axis. So along x-axis, acceleration is 0. We know already. So apply kinematic equations. V is equal to u plus at along x-axis, along y-axis. Here also we use kinematic equations. We have V is equal to u plus at along x-axis. V is equal to ux plus ax into t. We know ax is 0. So ux is vx. So at any instant, x component of velocity does not change. And its value is how much? So here we are projecting horizontally. So vx is always u. Initial velocity u. That is completely along x-axis. So similar formula, if you apply along y direction, Vy is equal to Uy plus Ay into t. So we get Vy is equal to Uy. Uy is Uy. minus gt. So this is the velocity along vertical direction. But see here, g positive, so plus g. G downward direction is positive, so plus g. So here uy 0. See one more step we can add here. uy 0 we can write because there is no vertical component initially. So finally Vy is equal to gt. At any time, vertical velocity is gt. So if we plot a graph, so we are actually projecting from building of height h onto the ground. So particle will follow this path. Suppose consider particle is at this position. O we projected. Finally, particle is at P. So at this position, it has velocity. V bar. Suppose initial velocity here it is U bar is U. U bar, magnitude of U bar is U. So just take U bar, initial velocity U bar in vector form. U bar completely along x direction at time t0. After time t, particle is now at point P. So it has two components. One is vertically downward direction, and other one is vertically horizontally right side, Vx. So this is the net velocity V bar. V bar is along the path. So at time t0, U bar is completely along x direction. After time t, now V bar is equal to Vx I cap plus Vy j cap. So Vx is U and Vy is gt. Vy is gt times j cap. This is, we know downward direction is positive. So that is the reason Vy is to here. Downward direction is positive. See, we are following this coordinate system. So direction is y, upward direction is minus y, right side plus x, left side minus x. So we are following this convention, that is positive. So finally we got velocity at any time. After time t, this is the velocity of the projectile. Similarly, you can also find the total time after which it reaches the ground. So using the second formula, we have along x-axis. We can also apply one more formula. We have kinetic equation. Along x-axis, along y-axis, also this formula s is equal to ut plus half at square. Along x direction, similarly along y direction, sy is equal to uy into t plus half ay into square. This equation also we can apply. See here, along x direction displacement is x. X is positive. It is right side. X is positive. So ux u into t at any time. So its coordinate is, so this coordinate after some time its x coordinate will be u into t, because ax is 0. X is equal to ut. This is the x coordinate of the particle. Similarly sy is y. Y is always positive because downward direction is positive. So uy is 0 plus of ay is plus g, downward direction is positive. So y is equal to half gt square. See, we can also find its coordinates. Situation, actually we were projected this particle from the top of the tower. So particle is following this path. Finally, it will fall on the ground. So its velocity initially u bar. At time t0, this is origin. At time after some time, this particle is now here. Its coordinates are x comma y. So its velocity we know v bar. Now we have calculated. So its coordinates we can find. This coordinate x means here. So this length is x. So this is x and y. Y means this height, vertical height. So this is y. Vertical distance from top. So this is, so coordinate is x comma y. So if you know instead of time, if you know distance, vertical distance, if you know, you can use the third equation along x-axis, kinematic equation, third equation, v square minus u square is to as. You can also use this formula. One more, the last equation, along x-axis as well as along y-axis we can apply. So along y-axis, vy square minus uy square is equal to 2ay into s. So along x direction, acceleration is 0. So vx square minus ux square. Finally, we get vx is equal to ux. We know already. So vx is equal to x, or we can also write vx is equal to u. At any time, x component remains constant, but y component, when you come to y component, vy square minus uy square is 0. Initially, there is no vertical component. Ay is minus g, no, plus g, because downward we are taking, and displacement is y always positive down direction. So we get vy is equal to root 2gy. So we can also express in terms of height traveled, vertical height traveled. Y is the vertical height, vertically downward direction. So we can also express like this using third kinematic equation. So this is the case 1. So this is the case 1. We are projecting horizontally from top of tower. Case 2. We go to case 2. From top of tower, from same tower, if I project a particle upward direction, suppose this is the ground, same tower, if I project a particle from here, making an angle theta with a horizontal, this is theta, with velocity u, so it will follow this path, parabolic path again, but like this. So now it will follow this. So now take that point is origin. At time t is projected. So time increases, and in this direction take x-axis, and the left side of this x-axis, upward direction positive y-axis, downward direction negative y-axis. Gravity downward direction. Gravity is downward direction, we know already. So this is called ay. Here ay downward direction is negative. So a minus g. X direction acceleration is 0. So we got everything. Just apply all kinematic equations. Follow the sign. Say can apply. Okay, So x-axis, along x-axis, along y-axis. Separately, apply all kinematic equations once again. So Vx is equal to Ux plus Ax in D. So here Ax is 0, Vx is Ux, but here Vx is U cos theta along x direction. So it is always Vx is Ux or Vx is U cos theta because it has x component U cos theta. So this particle has U cos theta x component and y component initially U sin theta. As time increases, its velocity direction changes. So next vertical component, what happens to vertical? Any x component is remains constant, but y component changes. So uy, see here it is not 0. Uy is not 0. Here it is upward direction. Uy u sin theta. And ay is minus g into t. So vy. So we can write like this. So here vy changes its direction, but vx always constant. If we plot graph, we plot the diagram. So in this diagram, we can represent Vx and Vy. So this is a building of high tech. We projected particle making an angle theta with velocity u. So it will follow. So at any time, say if you look at the x component, y and y components. So x component is this angle is theta. See this is theta. So in this direction we have x component Vx. So Ux initially it is Ux. As time increases, so Ux this is always Ux. At any time x component remains same. Its magnitude and direction remain. So it is Vx is equal to X. Magnitude and direction both are same. But if we go to one component in the above situation, particle will follow this path again. But now it has, we are discussing vertical component. So x component is Ux. Now we will discuss y component. Y component is Uy. Initially, as time increases, Uy decreases, and at the topmost point, Vy 0. At the point, Vy 0. As time increases, the vertical component increases. And finally, it will hit the ground with the highest speed. Vertical velocity very large, just before hitting the ground. So this is why. So Vy very large. So Vy changes. Vy is equal to Uy minus gt. That is the reason Vy changes. When it is going, Vy decreases. When it is coming down, Vy increases. Similarly, can also calculate displacement along x-axis and along y-axis. Along x-axis, s is equal to ut plus half at square. Apply second kinematic equation. So along x direction, now x is positive or negative? Positive. In the diagram, x is always positive because right side is positive. So we get ux is u cos theta into t, and ax is 0. So x is equal to u cos theta into t. At any time, x is always positive. X is so right side, horizontal right side, x-axis is positive, particle also moving right side, so positive. X is always positive. So this is a very important point. Next, we go to y coordinate sy, uy into t plus half ay into t square. So here sy is y, just y, uy is u cos sin theta into t plus half ay is minus, because downward direction is negative in this situation. See, if you look at this, first case, here we took g value negative, downward is negative, substitute minus g, so here finally we got y. This y can be, see, just like here we decided x is always 2. Here what about y? If you look at this diagram, the first y is positive, y it is going up and up, it is coming down. Now it crosses the origin, now it is below the origin, finally it is below the origin, finally it is negative. But y changes, y we cannot say it is only positive, it is negative. So here y continuously changes, sign value changes for y, that depends on t. At different times sign is different, so answer gives the sign value y. Here x is, here y is, y can be 0, negative and positive. Or negative, that depends on time. So in this way we use second kinematic equation. Similarly, use third kinematic equation along x-axis, along y-axis. So v square minus u square is equal to 2s along x-axis and along y-axis. This is the third kinematic equation applying vx square. So vx square means here x component and ux square is u sin theta, no, u cos theta, square cos theta is equal to ax 0. So finally vx is equal to u cos theta. Or you can substitute, first of all you can substitute ux as ux only. So we get, first of all, vx is equal to x. So same equation we are getting, or we can also write vx is equal to u cos theta. Same equation, x direction velocity always constant, but y direction vy square minus uy square. Here uy is u square n square theta, and ay is negative, always negative, g always negative, the first diagram. And sy, here sy, so we cannot say anything about sy, so write sy as sy only. If you know sy, if sy can be, here sy generally we direction substitute y can be positive, y can be negative, y can be 0, we know already. So this is the final formula, under root of q sin square theta minus 2gy. So this is the y direction, velocity along y direction. Here y can be positive, 0, or negative. Just now we have discussed in this situation also, Y can be positive, 0, negative. Anyway, the total Vy value is always, you should get positive, because under root, square root of negative value, say imaginary, does not exist. So Vy, so this inside the root you get always positive value. So these are the three kinematic we are using in this case 2. So this is the case 2. So first of all, we know how to take coordinate system. So here we are projecting up. So upward direction positive, right side direction positive. Similarly, last case, so case 3. So we are throwing again the same particle projectile from same building of high touch. So consider a particle. So it is projected like this in this direction with speed u, making an angle theta with horizontal. This is theta. So this will follow this path. So this projectile will follow this path. It will fall on the ground. So now we are throwing right side as downward simultaneously. So right side you can take positive. So take this as positive x-axis, and left side is negative x-axis. Upward direction is downward. So one component is downward. So downward is positive y-axis. Upward direction is negative y-axis. We know gravity always downward. Gravity you can take, so a vertical ay is minus g. It is downward, so plus g. Here it is plus because downward is plus. And right side ax is, so follow the same procedure. From where we are projecting, that is origin, and time is 0. So after some time it will follow this path as shown in the, so parabolic path only. Now x-axis and y-axis. Apply all kinematic equations once again. So V is equal to U plus AT. So here Ax 0. So Vx is equal to Ux. What is Ux here? So it's x component is U cos theta. In this direction U cos theta, and downward direction U sin theta. So we can also write this as Vx is equal to U cos theta. Next y-axis, Vy equal to Uy plus Ay into T. So here Vy to U and Ay is plus G. We know Uy is U sin theta plus Gt. This is the vertical velocity. Similarly, along axis, along y-axis, apply second kinematic equation. S is equal to ut plus half at square. Sy is equal to uy into t plus half ay into t square. So along x direction, see particle set. So plus. So it is always positive. X always positive. Ux is u cos theta according to the diagram, and ax is 0. X is equal to u cos theta into t. See, we are following this coordinate system. This coordinate system, right side is positive, downward is positive. So x is always positive and y also always positive. Y also always positive. So uy is u sin theta into t plus half ay. So here ay is ay vertically downward direction is plus g. the y coordinates. So here x, one important point here, both x comma y are positive. Both x comma y are positive. According to drawing system. Next, we use third kinematic equation along x-axis, along y-axis. So we have vy vx square is equal to 2as. So here ax is 0. So we get vx is equal to ux. Or we can also write vx is equal to u cos theta. Similarly, vy square minus uy square is equal to 2ay into 12. So here vy square, final velocity, uy square. So u square sine square theta. Vertical velocity is u sine theta. Substitute u sine theta and square it. Ay is plus g, downward direction. And sy is y are positive. See here, very important, both x, y always positive. They're never negative. Finally, we get vy is equal to under root of u square sine square theta plus 2gy. This way, so when you project a wheel from top of tower, we have three cases. We follow coordinate system. Fix your coordinate system and do not change coordinate system in the middle of the problem. So we'll see one application. Suppose a particle projected from so this is the first step, this is the second step, third step. So we can solve above using above concept. We can solve a ball is projected. This is the ball. A ball is projected with speed. Initial velocity u. U is given as 150 centimeter per second. With this speed, we are projecting a ball. So it is following this path, parabolic path. It will hit some nth step. So it will fall on the nth step. So given that width of the height of the each step is given. So height of the each step is this height is centimeter and width also 20 centimeter. So each height and each width given. Height of so given that the steps are 20 centimeter high and 20 centimeter wide. On which step ball hit first? That is the question. So this is similar to a ball projected from top of a tower horizontally. This is exactly similar. Suppose if ball hit a step, if ball hit nth step, so we can say it hits first step. So it will cover 20 centimeter downward direction. It will travel 20 centimeter downward direction. It will travel 20 centimeter right side. Then it first when if ball hits second step, it has to travel 20 plus 20, 40 centimeter downward and 20 centimeter, 40 centimeter right side. So in this way, so along x direction we take so in this above problem we take right side is positive x-axis and downward is positive y-axis. So we'll do here. So these are from ball is thrown. So speed 150 centimeter. Convert this into meters. So 150. So 1.5 meter per second. So gravity is downward. See, from we are throwing right side. So right side is positive x-axis. The right side is positive x-axis. From where we are throwing, that is time t0, and this is origin. And left side is taken as negative x-axis, and vertical upper direction is negative because ball is coming downward direction. So downward direction is positive. So follow this coordinate system and apply the same procedure. So ball will hit nth step. So it has to cover. Suppose if it hits nth step like this. So in this way, so this is the nth step. Suppose ball will hit somewhere on the nth step. So it has to cover x direction. Along it has to cover. Let it x. This is called range. So x will be equal to. So each width is 20 centimeter given already. So each step has 20 centimeter wide. So 20 like this. So up the step we can write n times 20. N times 20 centimeter. So we can 0.2 n in SI system. Similarly, y direction. In y direction, it has to cover total height. So total height, y coordinate, y. So y equal to, here also height of each is 20. So this is 20. See, this is 20 like this. Nth step, up to nth step, we can write n times 20. So y will be 0.2 n. To SI system, see both x and y are equal. So here, according to kinematic equation, S is equal to ut plus half at square. Apply this formula along x-axis and along y-axis. So along x-axis, see, given that from this information we know x is equal to y. X, y exactly, x and y exactly equal. So here x is equal to y. Apply the above formula along x-axis. So ux plus half ax into t square, uy into t plus half ay into t square. So ux is ut, that is equal to uy 0. See, x value is 0, we know. Uy value is 0. Initially we are throwing horizontally, and ay is plus g and t square. So tt can here g value downward direction. So that is the reason g value positive. So value positive. Now solve this equation, we get ut is equal to gt square by 2. T is equal to u by g. Already given u value 1. By g value take 10, get 3 seconds. So we got time. So then substitute this time in x and y. See, we know x is equal to ut. So look at this. So x is ut and y is half gt square. See, we know x is equal to ut. Time we know, and u also we know. U value 1.5. Time is 3. So this is x. So solve this. X is equal to 4.5. See here, this is not 3, 0.3. This is 0.3 seconds because this is 3 by 10, 0.3 here. We get so X value we get so 45, 0.45 meters. X value we are getting. X value we know already 0.2 times n, that is equal to, since X value 0.2 times n, so we get 0.45 meters. 0.45 meters. Now n is equal to 2.25 meters. So approximately, so not exactly, it will hit third step. So ball hit third step. 3. You can take 3. N is 3. Ball hit third step. So ball crossed second step. Why ball hits third step? Because ball crossed second step. So this is the first, second, third. This is the ball. The ball will hit third step. Not at the edge, in the middle. Somewhere here. So I call this is y, this is x. So here to here. So here to here, this is 2.25 meters. The x value 0.45, not 2.25, 0.45. That's 45 centimeter. That is 20 plus 20 plus 5. So 45. Because we know this width is 20. This, so just crossed, so cross second step. And it will hit third step. So similarly, it will also cover y distance. This y also same, 0.45 meters, or we can say 55 centimeters, exactly same, since x is equal to y. So in this way, we apply the above concept, projectile motion from top of tower. So for different cases, we take different coordinate system.